Here we are, just on a bright and chipper early Tuesday morning.
7:15.
Oh, man. We're here to serve you up another platter of knowledge. You like that?
Oh,
Serve it up?
yes, yes. Makes it very appetizing.
Ah, see what you did there. All right, so today we're going to focus on the different types of chemical reactions. So we've been working with the law of conservation of mass and knowing what you start with, you have to end with.
Yep.
And balancing equations because, of course, you got to have the same amount on both sides,
Sure.
just rearranged.
Yep.
So now we're going to talk about how to come up with those different types of reactions.
So what's happening more of?
Exactly,
Oh,
yes.
Cool.
So the first one is what we call synthesis. Now the word synth actually means to bring together. So as you can see when we do our thing here, we're going to take two elements or compounds, combine them to make one little product.
So I start with two things and I end with one.
Exactly.
Oh, okay.
Okay, so here's just a generic A plus B would yield AB.
Oh, okay. Start with two things.
And with one, yes.
Gotcha. Oh,
Okay,
ooh, look at that.
yeah. So then we have an actual chemical example where I would take two NAs, I would add it to a diatomic chlorine, and I would get 2 molecules of NaCl.
Okay. So I still start with two elements and end with one compound, but the balance never affects the type of reaction, right?
Exactly. So, for example, we have good old looking Brad Pitt, right?
It's nice that you just refer to him as Brad.
Yes.
not Brad Pitt.
No, he's
Like
just,
you're on a first name basis.
We are actually, yes. So we have Brad, and then we're going to add Brad to his blushing bride, Angelina.
Oh,
Okay, so, and then what comes out of this is Brangelina.
gotcha.
Okay, so two things. Now, they don't even get their own names anymore.
That's, yeah.
Yeah. Okay, pretty easy, right?
Right. There you go.
Okay. All right, so now we go to the next one, which is decomposition. Now, when you hear the word decomposition, what is the first thing you think of?
I think of like something decomposing or breaking down or kind of,
And kind of smelly,
Yeah.
usually, yes. Okay, pretty similar. All right, so we're going to take something, one compound, and we're going to break it down into 2 or more elements.
Okay.
Okay?
That's right. So the exact opposite.
Of synthesis. Yep. All right, so for example, we have AB now, and it's going to break it back down into its parts of A and B separately.
Okay.
Okay?
Straightforward.
So here's aluminum chloride, and we're going to break that down into aluminum and chlorine.
Oh, okay. That's nice and easy.
Yeah. So here's the example I have. You have a whole shell before that little turtle-y fella hatches.
Yeah, that guy's so cute.
I know. And then he cracks out, and you have turtle and shell.
Okie dokie.
There was really nothing much better than I could come up with.
No,
for that.
yeah.
So, okay. All right. Now we have combustion. Everyone's favorite types of reaction.
Yep. Flashy.
Kaboom!
Yep. Burn.
So this is when you have any carbon-based type of compound. So for our example is CH4. I apparently forgot to subscript that little 4.
That's
but
okay.
You guys know how to
Yeah,
do that,
got
okay?
that, yeah.
It's going to combine with oxygen, and it's always, always, always going to form carbon dioxide and water. No excuses.
Okay, so if I have something
Yep.
plus oxygen yields carbon dioxide and water, like I'm 99.9% sure it's combustion.
Absolutely,
Right? It
yes.
has to be carbon dioxide and water. Can't be anything else.
Right.
Okay.
Yeah, all the elements that you have in combustion reactions are carbon, oxygen, and hydrogen. That's it. You only have those 3 letters.
Nothing
CH
else.
and O. Nothing else.
Cho.
Okay?
CHO.
So, here's our example. I'm taking my methane, CH4, I'm adding oxygen to it, and it turns into carbon dioxide and water. Again, always, always, always produces carbon dioxide and
Okay,
water.
so I see carbon dioxide, water. I should think combustion.
Absolutely.
I wonder what our example is.
I don't think I have anything cool. Yeah,
wah,
sorry. I know. I couldn't think of anything.
What? It's
I know.
fire.
Okay. So here we have our combustion reaction. As you can see, those products on the right-hand side, the water and the CO2, are always going to be those two fellas.
Always. Never any exceptions.
Okay?
Ooh, single
Now we get to the
displacement.
fun ones.
Mmm.
All right, what I like to think is fun. All right, there's single displacement. So, as you can think of it, one element is singly going to displace another element.
Okay, so it's going to kind of slide in and bump another element out.
Absolutely. Okay? And that's because it's higher on its reactivity series, which we'll give you in class. We'll talk a little bit
Yeah,
about.
it's just a table. It's really not anything
Yeah, there's nothing
fancy.
fancy. It's like an addition to your periodic table.
Ooh.
What do they call it? An addendum? An amendment?
An addendum?
Addendum. There you go. So, for example, I have A plus BC. What happens is A is the cooler, if you will, element. So it takes the place of B. Now, the only thing that we have to remember with these displacement reactions is if we have a, for example, cation, it is going to take the place of another cation. It's not going to switch with an anion.
Gotcha.
Because you always have to have, if you're making a compound, a cation and an anion.
Gotcha.
So
A is going to come in. A is going to bump B out of the way. It's going to bond with C.
What up, dude?
That is exactly what it says.
Yeah, just like that. Okay, so here's, for example, we have copper plus silver nitrate. Copper is higher on the reactivity series than silver, so it's going to take the place and say, get out, buddy. And that's exactly what it says when it happens. Actually.
Yeah, because atoms have mouths.
They talk. So here we go.
Ooh, boy.
We have Mr. John Fox. Used to be the coach for another team. I don't know what team it is.
A football team.
A football team, yes. Okay. And then we have our buddy Tressman and Mr. Cutler playing for the Bears.
Gotcha. Yeah.
Okay. So in this case, Tressman was terrible. So he would be lower on the reactivity series. And Mr. Fox comes in and, boom, takes his place.
Boom.
See that?
Yeah.
Awesome.
He's offering Cutler a hug.
Yes, exactly. And then poor old Tressman is just out in the dirt. That's a pretty scary picture of him, actually.
Yeah.
Looks a little creepy. But, so Fox would take the place of the old coach, and therefore the old coach is out, new coach in, he's ready to rock.
Gotcha. Okay.
Okay.
That's kind of fun.
Yeah. All right, and double displacement. Now, does that sound like anything we just went over?
I feel like it sounds a lot more like single displacement than anything else.
It does. It does,
That's
actually.
amazing, yeah.
And it's just what you can think of. Two elements now are going to switch. Do the switcheroo.
Okay.
Okay? So two compounds are going to exchange ions and form two new compounds.
Okay, so instead of one coming and booting someone out, they're just going to swap places.
Yeah, I like to think of this one when I tell the students. It's like you and your buddy take two girls to the dance, and at the dance you realize, I like my buddy's girl, and then you guys switch dates and dance, of course. Okay?
That never happened.
Oh, okay. So for you have AB plus CD, and in this case, you're going to now produce AD and CB. Now, you may be a little confused. Why is that one backwards on the right-hand side?
What's going? Yeah.
What do you think? What did we talk about in the last one?
So a cation has to switch with a cation and an anion with an anion. So in this case, it looks like B and D are just flip-flopping places.
Absolutely, yes.
Okay.
Yes, because both of them are anions, so they have to switch places with the other anion. They're not
Gotcha.
going to form two cations and two anions.
That'd be ridiculous.
That'd be wrong-o with a big X.
Yeah.
Okay.
Like Hollywood Squares.
Yeah. Yes.
Is that what they do? No, Family Feud? I don't know.
No, I don't remember.
I don't watch daytime TV.
Okay, so let's take a look at what our real example is. All right, so we have hydrochloric acid here, if you will, and sodium hydroxide.
Yep.
And what happens is, as you can see, Na is like switching with the chlorine.
With the hydrogen?
I'm sorry, yes, switch to be with the chlorine.
Gotcha.
I apologize. And then we can produce water because our H's are going to go together.
Because H and OH is H2O.
Yes. So, and I realize it says H2
Zero?
not
Yeah,
H2O,
that's okay.
but you know, sometimes there's a slip up. Okay, so here we go.
Okay.
This is an example we should all be relating to. We got Jay Beebs here and his girl Selena.
Oh, boy.
Okay, and then there was an incident where Taylor and Taylor were together.
Oh, the
Okay?
Taylors.
The Taylors.
T cubed.
Right,
T-squared.
and then what happens is the old switcheroo happens, and you see pictures of Jay Beebs and Taylor.
Oh, man.
And
You knew it was
Selena
coming.
and Taylor.
Oh,
So Taylors were split, and they
Wow.
now have new partners. So
so sad.
yeah, I know it's unfortunate, but it did happen, and that would be our double displacement reaction.
Yeah.
So
Yeah.
okay, let's take a quick look. Here are a few practice
Whoa,
problems.
looks like fun.
All you're gonna do is jot these down and go ahead and you're not doing any balancing. You're just telling me what type you think they are.
Alrighty.
All right, we'll go over these in class. See ya.
Bye.